Hi, hello everyone. My name is Maisara Alia Faika binti Ramzi, the group leader for Group 13, and my matrix number is 221966. Together with my team's member, Lee Pei Ying, our scriber, Imran Nazmi bin Muhammad Gaddafi, ketiga anak perempuan Sivalingam, and Nur Izzati binti Tajuddin, we are excited to present our company, Clover. Clover is a chemical manufacturing company focused on sustainability and innovation. For this project, we have developed a website for Clover showcasing its use of a building process to produce high-quality hydrochloric acid.
Assalamualaikum warahmatullahi. My name is Nur Izzati binti Tajuddin. My matrix number is 230951. Okay, right now, what is hydrochloric acid? Hydrochloric acid is a colorless solution with a distinctive pungent smell. It is classified as a strong acid. Hydrochloric acid is an important laboratory reagent and industrial chemical. Being a strong acid, hydrochloric acid is corrosive to living tissue and to many materials but not to rubber. It can cause skin irritation and eye damage. The melting point of hydrochloric acid is negative 114 degrees Celsius and the boiling point of hydrochloric acid is negative 85 degrees Celsius. Okay, right now I will present about hydrochloric acid production condition. Firstly, the production of hydrochloric acid per annum is 0.5 million ton, and the feedstock that we get is potassium chloride and sulfuric acid. The purity that we should get for hydrochloric acid production is 99% in vapor and 37% in liquid form. And the method that we will use for hydrochloric acid production is Berlin process.
Okay, for potassium chloride, the physical state will be in a crystalline solid and the color is colorless. The potential hazard is may cause irritation with prolonged exposure on skin. Also, it can cause mild irritation on eye, and if you consume large amounts, may cause nausea or vomiting. So the precautions that we need to take is wear protective gloves and safety goggles when handling. The treatment is wash the skin affected area with soap and water. Also, rinse the eyes gently with water. Lastly, rinse the mouth with water and drink water to dilute the substance. Other than that, for hydrochloric acid, the physical state is in a liquefied gas. The color is colorless, but it is slightly yellow. So the potential hazard for this substance is highly corrosive substance, and it can cause severe burns on eyes or skin. Also, it can cause irritation to the respiratory system when consumed. A precaution step for this is we need to avoid using the substance without protection. Also, avoid breathing the vapor or the mist that is exit from the substance. The treatment for this substance is we need to remove the contaminated clothing immediately and rinse it with water. Also, we must flush our eyes with water if it is exposed to the eyes. Lastly, move the person to a fresh air to avoid from breathing the mist or the vapor. For potassium sulfate, the physical state of the substance is solid. The color is colorless or sometimes is white. The potential hazard from this substance is may cause mild irritation with prolonged exposure on skin. Also, dust can cause irritation or discomfort on eye. It can also cause dizziness, diarrhea, or vomiting when consumed. The precaution step for this is wear protective gloves and safety goggles when handling. The treatment when you are exposed to the substance is wash with soap and water to the skin. Rinse immediately with water and remove contact lenses if you wear any contact lenses, and rinse the mouth with water if it is exposed to the mouth. And also for sulfuric acid, the physical state is in an oily liquid. The color of the substance is clear and colorless. The potential hazard of this substance is a highly corrosive substance and can cause burns and tissue damage on skin. It can also cause permanent eye damage, including blindness, since it is a highly corrosive substance. Precaution for this substance is wear splashy-proof safety goggles and face shield. Wear acid-resistant apron and safety boots. And more importantly, use the substance in a smoke chamber, since it can release vapor and mist. For the treatment for this substance is flush the skin contact area and eyes with plenty of water, and seek immediate medical attention when you are exposed. Either you consume it or it is contact on skin.
Potassium bisulfate is a white crystalline solid with more significant hazard. It can cause skin burns and serious eye damage. Inhalation or exposure can also lead to dizziness and drowsiness. To handle this safely, we have to wear proper protective equipment such as gloves, goggles, and a lab coat. It should also be used in a well-ventilated areas. If exposed to skin or eyes, we have to wash immediately with water for at least 15 minutes. Do not induce vomiting if ingested. Instead, we have to seek for medical attention immediately. Although it is generally safe, but it can also pose hazard in extreme conditions. Hot water can cause burns while ice can cause frostbite. Water exposure can also lead to tearing and also blurred vision. We have to avoid contact with extremely hot cold water and prevent exposure to the ice. If frostbite occurs, gently warm the affected area with warm water. If burned, rinse with cool but not cold water. If it enters the ice, rinse thoroughly with clean water. While for sodium chloride, it is commonly known as aerosol. It is a crystalline solid that appears white in color. It is not considered as a hazardous substance but can cause drying of skin with prolonged exposure. It should be stored in any suitable container and kept in a laboratory product. If it comes into contact with the skin, we have to wash the area immediately with water. If accidentally consumed, we have to drink plenty of water.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Izzati binti Tajuddin. My metric number is 230951. So today I will present the first block diagram, which is this solution. Firstly, the stream 1 will be the fixed stock, which is potassium chloride, KCl, and also it has the impurities. The impurities is usually NaCl in KCl solid. The KCl will go into this solution block, which has the temperature is equal to 25 degrees Celsius and pressure is equal to 1 atm. The stream 2 for H2O also will go into this solution block to produce the aqueous solution of KCl in stream 3. After the dissolution block diagram, the aqueous solution of KCl will go into the evaporator block diagram. The temperature of evaporator block diagram is 120 degrees Celsius and the pressure is 0.8 atm. So the evaporator will evaporate the H2O and leave at the stream 4 to produce the KCl in liquid form at stream 5.
All of the substances that coming out from the evaporator will be channeled into the crystallizer. The crystallizer aims to promote the formation of solid KCl crystal from the supersaturated solution exiting the evaporator. In the crystallizer, the solution temperature is lowered to 10 degrees Celsius to allow the solution to reach supersaturation, forcing excess KCl to precipitate out as a solid crystal. The feed of crystallizer including KCl liquid, water aqueous, and NaCl liquid, whereas we have two other streams for crystallizer. For stream 6, we have uncrystallized KCl, NaCl as impurities, and water, while for stream 7, we contain only KCl crystal. In fact, KCl crystal is very important as a feed material to combustion chamber as it helps to remove impurities from KCl.
Assalamualaikum and hi, my name is Imran Nazmi bin Muhammad Gaddafi. My metric number is 228692. Okay, now I will explain the combustion chamber. Firstly, the first stream will be the potassium chloride enter that has obtained from the crystallizer. For the second stream is the sulfuric acid entered. The combustion chamber's pressure is at 1 atm and the temperature is 350 degrees Celsius. This is because we want to make the reaction further so it can obtain potassium sulfate as a product. The third stream will be the outlet of the reaction. Since this is a reactive unit, there will be some of the reactant exiting the stream. Since the combustion chamber is 350 degrees Celsius, most of the products will exit in the form of gas, except for the potassium sulfate, since it is not in the boiling point of the product.
The combustion outlet feed enters the three-phase separator as stream 9, containing a mixture of gases, liquid, and solid. So these components are separated into different phases to facilitate downstream processes. Our input is stream 9 from combustion outlet, and the molar flow rate of stream 9 from the combustion outlets includes the HCl in gas, H2SO4 gas, KCl, K2SO4, and KHSO4. Additionally, the system operates under conditions where the partial pressure of HCl is 0.041 atm, the partial pressure of H2SO4 is 0.313 atm. The three-phase separator operates based on the Roots law, which governs the equilibrium between the vapor and liquid phases. Using the partial pressure of component, HCl is separated into the stream 13 gas outlet. Its high volatility ensures it exits as gas when its partial pressure matches its saturation pressure. So the remaining component, H2SO4 liquid, KCl solid, and K2SO4 solid, and KHSO4 solid, are separated into stream 10 liquid solid outlet. H2SO4 transition into the liquid phase as its partial pressure matches its saturation pressure. So let's move on solid liquid separator. So we have input from stream 10, which is three-phase separator. So the feed from stream 10 containing a mixture of H2SO4 liquid, KHSO4 solid, K2SO4 solid, and KCl solid. So process in the separator is the solid liquid separator divides the feed into two distinct streams, which is stream 11 and stream 12. In stream 11, which is solid outlet containing the solid component, KCl solid, K2SO4 solid, and KHSO4 solid. So these solids are separated based on their insolubility in the liquid phase. And stream 12, liquid outlet, which is containing pure H2SO4 liquid, which is separate for future use.
Hi, I'm Ketika. My metric number is 229223. I will be discussing the process in absorption. Hydrochloric acid gas that produced from three-phase separator and water are fed into the absorption. The temperature increased to 40 degrees Celsius and the pressure at 1 atm. And the solubility of hydrochloric acid is 0.67. In absorption, HCl gas comes into direct contact with the water. When the HCl gas being absorbed moves from its original phase, which is gas, into the absorbing medium, which is liquid, it will produce two product streams. Firstly, hydrochloric acid dissolves in water to form hydrochloric in aqueous phase. It also releases H2O, which is excess from the reaction. Due to incomplete absorption, it will release the second stream. It also produces HCl gas and water vapor from evaporation caused by heat generated during the process. Next, I'll be discussing possible safety and environmental issues when producing hydrochloric acid by Berlin process. Hazardous compound involves are hydrochloric acid, sulfuric acid, and lastly potassium bisulfate. Possible safety issues and measures. Wear a lab coat and compatible gloves for skin irritation. Wear goggle and face shield to avoid eye irritation. Wear a respiratory mask and use chemicals in well-ventilated area or under a fume hood in the case of inhalation of toxic fumes. For spills, neutralize acid with sodium bicarbonate or lime and observe the liquid with inner material such as sand or vermiculite. And move on to the next, environmental impacts of hazardous compound mentioned earlier. Hydrochloric acid causes localized acidification when released, leading to damage to plants and aquatic ecosystem near the source of release. Next, sulfuric acid contributes to widespread acid rain which harm forests, acidic lakes and accelerate the degradation of buildings. Lastly, potassium bisulfate. It alters soil composition by increasing acidity, negatively affecting nutrient availability and plant growth in agricultural areas.